Okay, this is lesson 6.2, tangent properties. Again, we are looking at circles in this unit, and if you recall, a tangent line is a line that will intersect the circle exactly one time, so we're going to be working with circles and tangent lines and looking at a couple properties related to that. So in step 1, it says to construct the circle and label the center O. So we're going to go ahead and do that. So we've got my compass here. If you happen to have a compass, you should take that out and use that here to make a nice circle. I might just put my center point here first and then construct our circle. Okay, and then we're supposed to have center O, so we will label our center point O. If you don't happen to have a compass, do your best freehand circle drawing so that your sketch looks like what it is supposed to if you were using the tools or close to it. Second part here is to use your straight edge and draw a line that appears to touch the circle at only one point, that would be our tangent line, and label that point T. So anywhere you want on your circle, I'm just going to put my point T right here, and then I'll take my straight edge and make a line that goes through T. Again, this would be what we call our tangent line because it crosses the circle exactly one time. And then we are supposed to construct our radius OT. So take your straight edge again and draw a segment from your center point O to that tangent point T. Now our objective here is to measure the angles at T. So take your protractor that you have, hopefully. If you don't have a protractor, then just follow along here. And take that and measure that angle, and you might be able to guess what that is supposed to come out to be there. It certainly looks like a 90-degree angle, and in fact it is. And it kind of depends on how precise your drawing was here for what angle you're going to get, but it should be right around 90 degrees. If we had drawn it perfectly, it should be a 90-degree angle. You can see that's going to be true on both sides there, so angle OT, and then if we had to point up to the top part, let's call it, say, A, so OTA or OTB, both of those angles are going to be 90-degree angles, so that right there, and you can mark in the diagram with right angles on both sides there. So what can we conclude about the radius OT and the tangent line at T? Well, hopefully you can see that they are going to be perpendicular to each other. So the tangent conjecture says a tangent to a circle is perpendicular to, so is perpendicular to the radius drawn to the point of tangency. And so you might be able to just make an arrow up to this drawing up here, and that will be good enough for our conjecture. Okay, so any radius is going to be perpendicular to the tangent line that goes through that same endpoint of the radius. Okay, investigation 2 is construct a circle again, and then we're going to label the center point E on this. So I'm just going to go back up and grab my compass and my protractor here. Bring those back down again. Bear with me here. Okay, we've got our compass. Again, I'm just going to make a center point first so we don't lose where that center is going to be. And then we will make our circle. Center point is at E. So we'll call it E. Okay, step 2. Choose a point outside the circle and label it N. So by outside the circle, we literally mean outside of the circle. So if I want to put a point outside, I'm going to call this point N out here. All right, and then it says to draw 2 lines through point N tangent to the circle. Mark the points where these lines appear to touch the circle and label them A and G. So if you take your straight edge, go from N, and then try to just hit the tangent or point of tangency on the circle. So you just want to hit that circle one time here. So let's say right about there. And then do the same thing, because if you look down at the bottom, you should be able to also draw another tangent from that point. And sometimes it's hard to get the exact point of tangency, but something like that right there should be fine. So we're going to label them A and G according to the directions. And it says use your compass to compare the segments NA and NG. Now you could also take your ruler. The idea here is to compare their lengths. And as you compare their lengths, if I'm doing it on the board here, and I'm looking at them, and let's say centimeters, let's see, that appears to be, for me, about 28, 29 centimeters. And then the same thing on the other side, 28, 29 centimeters. The more precise you are, the closer your measurements are going to be, but segments NG and NA are going to be congruent to each other. So we can take our pen and put little congruent marks on either side here. So NA and NG are congruent. So these segments are called tangent segments. Notice it's NA and NG. I extended those segments a little bit past points A and G, but the actual segments NA and NG are called the tangent segments. So looking at the conjecture, it says tangent segments to a circle from a point outside the circle are congruent. So no matter where we would have chosen that point outside of the circle, if we drew the two tangent segments, those two tangent segments are going to have the same lengths.